In the silent expanse of the cosmos, where time stretches beyond the limits of human comprehension, there is an astonishing phenomenon that speaks to the heart of creation itself. It is the final act of a star's life, the supernova. These stellar explosions are among the most dramatic events in the universe, where a dying star erupts in a burst of light and energy, scattering its contents far and wide. But what we often fail to recognize is that the death of a star is not a finality. It is not an end but a new beginning, a cosmic transformation that leaves behind stunning remnants, delicate and complex, which continue to evolve for millennia. These remnants are the universe's most breathtaking masterpieces, cosmic art painted across the void with the brushstrokes of dying stars. When we look at a supernova remnant, we are not merely witnessing the aftermath of a death, but the brilliant aftermath of creation, a celestial tapestry that tells the story of the universe's deepest processes. The gas, the dust, the brilliant bursts of color. They are not just scattered debris. They are the very building blocks of new stars, new planets, and new galaxies. They are the raw materials of life itself, scattered across the cosmos to shape the future. Consider the Crab Nebula, a dazzling work of cosmic art. What was once a massive star, its life ending in a brilliant explosion, now lies in the intricate cloud we see today. The Crab Nebula is the remnant of a star that exploded in 1054, an event so bright it was visible in the sky during the day. Today, the remnant continues to expand, and at its heart, a pulsar, a rapidly spinning neutron star, releases energy in the form of light and radiation, its heartbeat echoing across space. This is not just a relic of a single star's death. It is a continual act of creation, a remnant teeming with energy, life, and the potential for something new. But how does this process unfold? The death of a star, when it reaches the end of its fuel supply, is a moment of intense pressure and collapse. In massive stars, the core implodes under gravity's relentless pull, creating a supernova explosion that releases an amount of energy far greater than the sun could ever produce in its entire lifetime. The outer layers, once composed of hydrogen, helium, and heavier elements, are blasted outward in an explosion of unparalleled power. What remains is a rapidly expanding shell of gas and dust, what we call a supernova remnant. These remnants are not static. They expand, grow, and interact with the surrounding environment, becoming the birthplace of new celestial bodies. As the explosion expands outward, the remnants take on a variety of shapes and forms. Some look like delicate filaments, tendrils of gas stretching across the heavens. Others appear as spherical shells, their edges glowing with the light of billions of excited atoms. The colors we see are not just random. They represent different elements, each element emitting its unique hue when energized by radiation or shock waves. Red, blue, yellow. Each color tells us a story about the chemistry of the star that exploded and the interplay of forces that created this awe-inspiring display. These remnants are like fingerprints, telling us not only about the star's composition, but about the immense forces of nature that shaped it. Look at Cassiopeia A, a stunning example of complexity and chaos. This remnant, one of the youngest known to us, is the aftermath of a star that exploded around 330 years ago. As the shockwave from the explosion travels through space, it interacts with surrounding gas and dust, creating knots and filaments of material. These interactions give rise to delicate, intricate structures, each one the result of millions of years of stellar evolution and cosmic dynamics. But what is most remarkable is that Cassiopeia A continues to evolve. The gas and dust are still being shaped by the forces unleashed in the explosion. This remnant is an ever-changing landscape, reminding us that even in the aftermath of death, the universe is alive with motion, change, and growth. The Tycho supernova remnant tells a similar story, but with a unique twist. This remnant is the result of an explosion observed in 1572 by the Danish astronomer Tycho Brahe. Tycho's observation marked a turning point in our understanding of the universe, for it challenged the belief that the stars were fixed and immutable. Tycho's supernova showed that even the stars themselves are subject to the forces of birth and death. The Tycho remnant, with its symmetrical ring of gas and dust, is a visual reminder of the dynamic, ever-changing nature of the cosmos. Stars are born, they live, and they die, but in their death, they give rise to new possibilities. These remnants are the raw materials for the next generation of stars and planets. Every supernova remnant we observe is unique. Some appear as intricate networks of gas and light, others as grand, sweeping clouds of color and energy. Some remnants are bright and fiery, their cores illuminated by the energy of a pulsar or a black hole at their center. Others are more subdued, glowing softly as the material gradually cools and disperses. What unites them, however, is the incredible variety of forms and structures. Each remnant a snapshot of the cosmic forces at work, each a unique expression of the universe's ongoing dance of creation and destruction. These remnants, though born from violent explosions, are not just debris. They are the harbingers of life. The elements they release, hydrogen, carbon, oxygen, nitrogen, are the very ingredients of life. The material flung into space will eventually condense, giving birth to new stars, new planetary systems, and, in some cases, the conditions for life to emerge. We are, in a very real sense, stardust. The very atoms that make up our bodies were once forged in the hearts of stars that exploded long before the Earth was even formed. The death of one star paves the way for the birth of many more. It is a reminder that life, like the universe itself, is a never-ending cycle of birth, death, and rebirth. The universe is an artist, and every supernova remnant is its brushstroke. A moment of cosmic beauty, created in the blink of an eye, yet lasting for millennia. These remnants remind us that the universe is not static, not unchanging. It is a place of constant evolution, where even the end of one thing is the beginning of something new. Supernova remnants are not simply vestiges of a dying star. They are evidence of the ongoing creativity of the cosmos, constantly creating, destroying, and recreating. As we gaze into these remnants, we are reminded of the vastness and complexity of the universe. Every explosion, every remnant, is a moment frozen in time, an eternal reminder of the impermanence of all things, and yet, the incredible beauty that can arise from the most violent of ends. These remnants are not just remnants of stars. They are the living, breathing evidence that the universe is always in motion, always creating, always changing. They are cosmic art, created in the death of stars, but living on in the hearts of new worlds. In the grand tapestry of the universe, every supernova remnant is a verse in an endless cosmic poem. Every explosion a story told in light and dust. And as we look upon them, we are not just observers. We are participants in this eternal cycle. We, too, are made from the same elements, the same stars, the same cosmic dust. In a way, we are connected to these remnants, as they are to us. For in their death, there is life. In their destruction, there is creation. And in their beauty, there is a reminder that even in the most violent of endings, there is the potential for something extraordinary to arise.